In early 2025, NASA's Curiosity rover made a discovery on Mars that has left scientists both excited and deeply concerned. While analyzing soil samples from what was once a Martian lake bed, Curiosity detected long-chain hydrocarbons, complex, carbon-based molecules like decane, undecane, and dodecane. These aren't molecules typically associated with the Martian environment. In fact, their chemical structures closely mirror organic compounds found in Earth's biosphere, often considered indicators of biological activity. The presence of these substances in such an unexpected context has sparked a wave of speculation. Are we witnessing evidence that life, perhaps even life from Earth, has already reached Mars? The implications are profound. If the molecules are Martian in origin, it could point to past or even existing life on the red planet. But if they're from Earth, they may suggest that our own activities have already contaminated Mars. Either possibility reshapes how we interpret every previous and future data point collected from the planet. NASA is now being forced to reconsider decades of exploration strategy, and the scientific community is scrambling to determine the origin of these organic signatures. This all began when Curiosity drilled into mudstone in an ancient Martian lakebed, a location long believed to have once supported conditions suitable for life. The rover's onboard instruments revealed a suite of hydrocarbons that are extremely rare in Martian chemistry, but common in Earth-based biology. What makes this even more troubling is the pattern and concentration of these molecules. They resemble biosignatures that, on Earth, would almost certainly be attributed to living organisms. But the story takes an unexpected turn with revelations about NASA's own equipment. Years ago, during the assembly of Curiosity, engineers attached a drill bit after the rover had already undergone its full sterilization protocols. This meant the drill bit wasn't subject to the rigorous, deep cleaning procedures designed to eliminate any trace of Earth life. NASA acknowledged this deviation in official mission documentation. Ironically, this same drill bit was used to extract the very samples now raising alarm. That oversight introduces a serious possibility that what we're seeing in these samples could have been transported from Earth aboard Curiosity itself. This isn't mere speculation. Studies of NASA's ultra-clean assembly environments, known as clean rooms, have uncovered disturbing facts. Despite extreme sterilization efforts, researchers found 215 bacterial strains in these rooms, 26 of which were completely new to science. These microbes weren't ordinary. They had developed capabilities to resist radiation, vacuum, and ultraviolet light, the very conditions faced during interplanetary travel. Some could even repair their own DNA after radiation exposure or enter dormant states requiring almost no water to survive for extended periods. The presence of such resilient organisms in clean rooms, combined with the known procedural lapse involving Curiosity's drill bit, strengthens concerns that microbes from Earth may have already made the trip to Mars. If they did, they could be responsible for the organic molecules now turning up in Martian soil. Even though NASA employs multiple layers of sterilization, including alcohol wipes, hydrogen peroxide vapor, and heat treatments, completely eradicating microbial life from spacecraft remains nearly impossible. To help guard against this possibility, NASA has deployed sophisticated systems aboard its more recent missions. The Perseverance rover, which landed on Mars in 2021, carries witness tubes, sealed containers filled with inert material that remain closed until a sample is collected. These tubes are designed to trap any Earth-based contaminants, acting as controls to help scientists distinguish between Martian organics and materials that might have come from the rover. Similarly, Curiosity uses control samples called blank organics to detect contamination during analysis. These systems are now under intense scrutiny. NASA scientists are comparing the hydrocarbons found on Mars to those detected in the witness tubes and blank samples. If the molecules match, the contamination hypothesis gains weight, but if they don't, it deepens the mystery. One of the key challenges is that the organic molecules being found, while unusual for Mars, aren't unique to Earth. Carbon-based life tends to leave behind similar chemical footprints, regardless of where it evolved. That makes the job of telling Martian and terrestrial sources apart incredibly complex. This complexity underscores a larger concern: the possibility of false positives. The scientific community fears a scenario in which signs of life are detected, only for it to be later revealed that those signals were left by Earth organisms that hitched a ride. Such an error wouldn't just be embarrassing, it could undermine trust in space exploration data and future missions. To make matters worse, Earth microbes are known to evolve rapidly under extreme conditions. Research aboard the International's space station has shown that exposure to space can trigger changes in microbial DNA, potentially making them harder to identify or distinguish from alien life. And this isn't just theory. There's the additional puzzle of methane on Mars. Since 2013, Curiosity has detected mysterious spikes of methane in the atmosphere, gases that should break down relatively quickly in Martian conditions. Their presence implies an ongoing source. While geological activity could explain this, biological sources can't be ruled out. In fact, some lab experiments have shown that Earth microbes exposed to Mars-like conditions can produce methane. The timing of these methane detections, occurring years after our spacecraft arrived, raises uncomfortable questions about whether these emissions might be metabolic byproducts from Earth, organisms surviving on Mars. This brings us to perhaps the most consequential project of all: the Mars Sample Return Mission, planned jointly by NASA and the European Space Agency. This ambitious endeavor aims to bring back actual Martian soil and rock samples to Earth by the 2030s. But if contamination is confirmed, or even suspected, it could compromise the entire mission. Billions of dollars and decades of planning could be at risk. NASA's own Contamination Review Panel is now tasked with the daunting job of ensuring these samples are truly Martian, not the result of Earth-based biological hitchhikers making a round trip. If Earth microbes are found in the returned samples, it could derail not just the sample return mission, but all future exploration of life-bearing environments across the solar system, including Europa and Enceladus. Such a discovery would force a total rethinking of planetary protection protocols. Even more troubling is the idea that contamination could destroy the very evidence of alien life we've been searching for, either by outcompeting Martian microbes or altering the local environment in irreversible ways. So, where do we stand? What we know is this: Curiosity has detected hydrocarbons on Mars that resemble biological materials from Earth. We also know that bacteria with extraordinary survival abilities have been found in NASA's clean rooms. And we know that a crucial drill bit used to collect Martian samples bypassed standard sterilization procedures. But what we don't yet know is whether those hydrocarbons are Martian or Earth-based in origin, or if the methane signals are biological, geological, or a product of contamination. What's certain is that this discovery has complicated the search for life in ways we never anticipated. NASA is now relying on its witness tubes and control samples to provide clarity in the coming months. Those results could definitively confirm contamination, or open the door to the possibility that something truly alien is leaving its mark on Mars. Either way, this situation forces us to confront an uncomfortable truth. In our quest to explore the cosmos, we may have brought a piece of Earth with us, potentially blurring the line between discovery and contamination. In the end, the greatest obstacle in our search for extraterrestrial life may not be the vast distances or harsh conditions, but the biological legacy we carry with us into space. This unfolding story is a reminder that space exploration isn't just about what we find out there. It's also about the discipline we need to preserve what's already there, untouched and unaltered, so we can recognize alien life for what it truly is, if it exists.